Hey guys, welcome back to my videos. My name is Ashish and today I'm going to demonstrate to you how to use reinforcement learning algorithm, specifically proximal policy optimization, that is PPO algorithm, to train a model and to play with a Lunar Lander game. So first of all, I will show you how to play the game manually, then and we'll dive into a training a model using a stable baseline 3 library. So as you can see screen, so this is the game where we are supposed to land our lunar lander module safely to the target that is between these two flags. So for that, we are going to use the stable baseline 3 library, and we are also going to use this game. The environment is provided by Gym, GYM, and it is released by OpenAI. And now there are two repositories, the Gym, the Gymnasium. Okay. So, uh, and if you are interested to know more about this reinforcement learning, so this is pinning up openai.com. So I'm going to share this link, but here you will get the basic idea, basic philosophy about this reinforcement learning algorithm. So in one liner, reinforcement learning RL is a machine learning approach for teaching agents how to solve tasks by trial and error, and deep RL refers to a combination of RL, that is reinforcement learning, and deep learning. So in PPO, just like the I mentioned PPO, right? So this is a paper. This paper was submitted by OpenAI in 2017-18, and so you can see here date 2017. And using this algorithm, at that time, OpenAI agents were able to defeat the Dota professional players in a professional tournament. So this story you can Google and you will find more interesting stuff about this agent. And this agent was trained by OpenAI for approximately more than 10,000 hours. And then after that, that agent was able to defeat that professional players. So let's get started. So I have created one simple demo lunar lander.py, and let's look at this game. So how to play this game manually, that is what I'm going to show you first of all. So I'm going to create environment. So you have to install pip install gym, and so for that, these are the two commands that you have to use. Open the terminal. So first you will fire command pip install gym, and then so I have already installed these things, so I don't have to install this again. I'm just showing you for the information. So I have installed it already. Pip install stable baseline 3. Okay, so this package is also installed, so requirement is already satisfied on my local machine. So next we are going to install pip install gymnasium. Okay, so yeah, so now we are going to import gymnasium as gem, and we are going to create environment from this gem dot make, and we are going to create environment for lunar lander, it is V2. Okay, and the render mode is going to be equal to RGB. Okay, so now environment is created. The next thing is I want to play this game. Okay, so for playing this game, I'm going to, from gymnasium, I'm going to import play, and this play function, in this play function I'm going to pass environment, and you need to pass key mapping, because we are playing this game manually, right? First of all, I want to show you what is the game, and here the key mapping looks like this. The W key will be action number 2. So I'll explain shortly what is action number 2A, and how to actually find out these actions WA and D. Okay, so you can choose any other key of your choice. So here the W stands for middle engine. So let's go to if you want to look at this Lunar Lander documentation, you can actually go inside this library. Here inside this virtual environment, you can go to lib, and here if you look at this gymnasium, it's alphabetically. You can just drive. You can go to this. Is there gymnasium? Is there here inside environment? So Lunar Lander falls into box 2D game category, and here you will see Lunar Lander. So this is the code of Lunar Lander, and here you will find all actions. So so here also you can see, you can run this command. If you have a source code, then you can just pass this command and see heuristic landing, or if you want to play, then you can run this. So W stands for the middle engine, A stands for left hand side engine, and 3 stands for right hand engine. So that information you will get here. What possible actions are there? Yeah, so here 0 is nothing, 1 is fire left orientation engine, 2 is fire main engine, and 3 is fire right orientation engine. So that's what we have done. Right is 3, 1 and 2, right? 2 is main engine, so middle engine is W. Okay, WAAD. Now the next is we have to specify the no operation. As they have mentioned, no op is 0. Okay, 0 is do nothing, and yeah, so that's it. I can play now this game. So I'm running this, and so it is saying from, okay, so it's from gymnasium utils dot play. Okay, okay, so now the game has started. Now we start controlling. So you can see it's very hard game. My score, I'm hardly able to do anything. Yeah, now I was able to control it, but it's yeah, now I think I will be able to score something, but no. So this is how, so I'm actually playing through, I'm trying to play via keyboard using WASD, and you can also try. Okay, so this is how I'm trying to play, and you can see it's really difficult game. Yeah, I was able to land once. So if you want to, now I'm going to show you how to look at the score. We can plot real-time chart. For that, I'm going to need one simple callback. So I'm going to write one callback function like this. So this callback, we are actually going to use one play plot. Yeah, this play plot function, and we are passing this callback here. Callback equal to plotter. So we need to create one instance. So let's create plotter dot callback, and let's create one. Yeah, plotter equal to play plot instance. Here I'm going to pass this callback that we are going to create 50, and we are interested in printing reward. Okay, so from this callback we have observation space, then we have TPL action reward. So this is what we are going to print. We are interested in printing reward, truncated, and info. Out of that, we are going to return just reward. Okay, that's it. Okay, so there is, okay, callback is done. Now let's try to run this. So again, we are running in manual mode, but now you can see the chart is printed. So as you can see on left hand side, the score is still 0. And if I'm able to successfully land, then my score will be 100. Let's try. Yeah, so I was able to land. Now I should get at least once. The reward should be 100. Okay. Yes, you can see this dot, right? So now I'm going to close this, and now we are going to look at how to train agent to perform this task. The agent will learn and it will try to land this lunar lander for you. Okay, that's the important part of this video. So let's go ahead. Now what I'm going to do is I'm going to comment this code, and I'm going to keep environment as it is, and or rather let's delete, or rather let's keep it here. I will write demo 1 play game manually and see the feedback. Or reward. Okay, so we received reward 100 once. Okay, now environment we have made is RGB array. I'm going to make it human. Rather, let's comment this, and I will shift this line so that you can use this code. So demo 2 is train agent using PPO. Okay, so for that we are going to use stable baseline 3. Okay, so let's create environment again. So gym.make, let me copy paste this, and I will be using, just I'm going to make one change here, that is human. Okay, so we'll be able to see what's going on. Okay, second, let's train the agent. So now what we are going to do is we need PPO policy from, we are going to import PPO policy from stable baseline that we have installed here, stable baseline 3. Import PPO. Okay, and using this PPO, so we are going to use MLP policy from PPO. We are going to pass environment equal to, so we want a verbose. And one thing I'm going to make here is to see what's going on. I'm going to add here logs. Okay, I'm going to add log tir equal to, so I'm going to create one directory PPO. So as you can see, there is no directory. So I'm going to create PPO underscore Lunar Lander tensor board. Okay, so here logs will get dumped, and we can, from that logs we can actually see where the reward is going, average reward. So steps that I'm going to use here is so 1 lakh. Okay, so that will get plenty of, so it is going to take some time, but we'll make sure that we will get some predictable result. Our agent will get enough time to learn from this environment. So that's why time steps I have written that much. Okay, so next is model.learn total time steps, that we are going to pass time steps, and we also need progress bar. Okay, so that on console we'll see how much progress we have made, and we are going to save this model. There is one more thing that you can always do. We can add a callback here, and we can monitor the reward we are getting, and we can print that reward. And once we have that reward around 100, the maximum, we can save and stop, or rather we can save the best model available. Right? Okay, so let's go ahead. So saving is done, and after saving, what we are going to do is we are going to delete this model. Okay, in from memory, not from the file system. Then I'm going to load this model again. PPO.load. Model name is going to be this one, and using this model, we are using same environment. Using this model, what we are going to perform is we are going to actually play the game again, see how our model is performing. Okay, so for that we need evaluate policy function from baseline, and that is available from gymnasium dot from stable common dot evaluation import evaluation policy. Okay, so this policy function is going to evaluate the policy by just looking at the model. So we are loading model from file system. So here get env is a function, and in the episodes that we are going to pass integer as a 10. Okay, so after that we create virtual environment wrapper model dot get env. So observation equal to bec dot set. So this code is pretty much available in the documentation, which I shown you for I in the range. So we are going to predict the next step using our model observation, and so this is a deterministic. So there is another version of Lunar Lander that is continuous or stochastic, where steps are discrete, not steps are continuous, not discrete. So it is actually more realistic, and it is stochastic is used in mainly in automatic driving, where you need continuous feedback, and so that steering will get continuous feedback, so that it can operate more gracefully. Okay, so last is human. Yeah, and when done, if done, then I'm going to print the reward. Okay, so let's see how many times we receive reward. I'm expecting 100 here. Like you can recollect when I was able to land that lunar lander correctly that time. Okay, so now what I'm going to do is I'm going to run this. It is going to take a lot of time. Okay, but let's see. I'm going to run this. So yeah, it is using monitors. So now you can see the progress is started. Okay, so let's wait for some time. So meanwhile, what we can do is while this is going on, I'm going to create one more terminal here, and while that progress is going on, I'm going to run this tensor board command, and I'm going to pass log dir as what is the directory name, PPO. Okay, so let's see if we have any directory created. So here I started getting feedback, and here you will see the thing I'm supposed to look at is yeah, so reward mean is the thing which is now way less, minus 155. So I'm supposed to get this somewhere around, so first of all it should be positive, and so if I win, then I will be getting 100 here. Okay, so you can see just like our manual efforts, initially it is going to try, and initially the failure rate is higher. Okay, let me see why directory is not created. So I'm just stopping, and we are going to try it again. So I'm going to add one line here. So the environment I'm supposed to wrap in monitor, so that this log dir will get created, and will get the real time. Okay. So I'm going to make one more change here. I forgot to add. So model instance, when we are creating here, I'm supposed to add TensorFlow log equal to log dir. Okay. So now we'll start again. So now let's go and check if, yeah, PPO directory is now created. Okay. So this is a current ongoing monitor.csv. Now what I can do is I can go here, and we can actually start TensorFlow. Yeah. So this is the agent which is training. The training is already going on, and you can see the progress here. It's a 0%. Okay, but we can see now through the graph, the progress. We can, let me refresh this. Yeah. So now I can actually see. You can see the reward here is very less. So if you remember, when we started playing manually, it was the same thing. The agent failing miserably, and as time passed, we learned, and from that, our performance, that is the reward, was improved. So same thing we can expect here. Here what I have done is refresh reload data is automatically given as a 30 seconds. So automatically it will get refreshed. And here also we get some input, but this is obviously not represented properly. So here I can see the reward that we are interested in, this reward, which is now minus 192. Okay. So let's wait for some time and see where we are heading to. So you can see now somewhere we have just finished 1% of training time, and now slowly you can see the reward is getting updated. So let's see what happens. So in just 2% of training and 8 minutes passed, we have reached to almost from minus 197 to minus 127. That is 118 now reward. So you can see the rate of progress is very high initially, and we can see some drastic changes initially. After some time, I'm expecting once it reaches to its threshold, that is 100 or 80, 90, we are going to make a slow progress. So please stay tuned. We'll again check after some time. So let's look at number of times. So we have completed around 37,000 steps, and we are just at 4% of our total training time. And here I can see we have already reached to minus 78, from minus 197 to minus 78. So let's see. All right, let's check. So yeah, so currently you can see we have completed 45k steps, and approximately 16 minutes have passed, and we have already reached to minus 40. Okay, minus 40. So you can see here we have completed 5% of the training, and yeah, so reward is 37. That will get updated shortly here. So this chart will get updated shortly, but you can see the progress from 197 to minus 37 in just 16 minutes. Okay, you can see now the chart is updated. So now we have just completed around 49 minutes of training and around 127k steps, and let me show you. So it's around 13%, that is 1,29,000 steps, and the reward is now positive. Okay, so 2.39. So you can see we started the initially the learning was very reward, we progressed very fast. Then after that, now we are moving a little slowly, and as I mentioned, slowly we will hit a plateau. So there is plenty of time for that. So right now we have just finished 50 minutes of time. So yes, so please stay tuned. So currently we are done with 1 hour 51 minutes of training and around 280k steps. Okay, and we have reached, so maximum we have reached is 38 positive 38 reward, and currently you can see it's a temporary value is down, and you can see on the right side the a computer or agent is now playing very smart game. Okay, so you can see it's very stable now. If you remember earlier, it was just like manually, yeah, so something similar was happening, but now it's learning and it's slowly improvising. So yeah, we'll again check after few minutes, so please stay tuned. All right, so we have passed around 430 steps, that is let me show you, it's around 43%, and you can see plenty of steps left, and uh, we have seen some drop in a reward, but after some time we have seen, so there is a significant rise in a reward, mean reward, and currently it's somewhere in between 71 to 65, and I'm hoping in next few iteration slowly we'll get past to 80, 90, and eventually 100. So yeah, so stay tuned, we'll again check after some time. All right, so we have completed around 68% of total time steps, and you can see the reward is somewhere around the value that we are looking for. It's around 106, 103. So that means actually if you see the game, we can see it's very stable now, but still, yeah, it's landing safely. May not be at the target, but still landing safely. So let's see what happens when we complete. We are almost there, and you can see it's 99%. Let me open. Yes, so you can see the reward. We are getting somewhere around 138. Okay, total 6 hours 28 minutes, and we are very close to about to complete our steps. And you can see here our lunar lander is landing. It's not exactly landing at the desired destination, but every time whenever it is landing safely. Okay, so let's wait for a few seconds, 1 minute. So after that, once this model is we are right now here, this learning phase is going on, then model will be saved, and after that, so let me, so yeah, it's about to complete. So this is the old file, it will overwrite this file. I will show you the timestamp of this file once this step is completed, or rather I can do is I can delete this quickly. Yes, I deleted. Okay, so what we have to do is after that we'll be loading this model again in this code, and then we'll from model we will run few steps, and will print reward if there is a turn. So we are successful in landing our lunar lander at the desired position, then we'll print the reward. Okay, so we'll also check the log here, console log. Looks like we're about to finish. I think it's the last iteration. Yeah. Okay, so now 100% completed. Now actually we have loaded this model, and you can see this model file is created on the left hand side, and now we are playing the game with our model. Okay, so you can observe from your naked eyes only that the performance of this lunar lander is drastically improved. Yes, you can see 100, right? It's printing minus 100. Okay, so you can see 100. Now if I want to use this model again, what I'm going to do is I'm going to simply comment this code, and I'm just going to load this. Okay, I'll need just environment, and I will run again. So now we'll be using this model which is created. I'll show you the timestamp. Yeah, you can see it was just created 220 to 3 minutes back. Okay, so now we are running it from our model, and we'll keep eye on this reward that we are printing. So ideally we should get 100 at least once during this trial. Yes, successful landing. So I'm expecting positive 100. So you can see 100, again 100. All right. So that's it from this video. Thanks for watching my video. Please like, share, subscribe if you are liking the content.